of these litter colors, the puppy colors, we will talk what kind of colors we will get if we put together a different color of parents. I'm losing my English here, but shortly, can we just take the two last ones from these gene letters, so called?
E. What I've heard talks about when it comes to, the confusion of two reds giving a brindle and everything, that no, these dogs are actually recessive reds. And this is where we come to the E series. This is the series that either has is a full red dog, or which is top dominant, marked by 2 capital E's, or 1 capital E, whatever. Mask is affected by the E series, which
so
is.
So you see red dogs with the black mask.
Yeah, you can have a red dog with a mask. You can have a brindle dog. You can have a tricolored dog.
Yeah.
With a mask, and the lowest on the ranking there is 2 lowercase e's, which is recessive E, and that dog can have a brindling gene. That is true. And what this recessive E does is it prevents any black hairs on the body. You can look at a dog, its whiskers, eyelashes, into the coat. If there is a single black hair on that dog, they are not a recessive red. This is something that people are like, oh yeah, they're recessive red. No, white can cover this, meaning that if the dog has lack of pigment somewhere, obviously you won't be seeing what color their eyelashes are if they're just white. But if the dog has red eyelashes, cream eyelashes, if the dog has a shred of shading in their red, this is not a recessive black anymore. And if you breed together 2 recessive red, if you breed together 2 recessive reds, you are still not going to get a brindle, because all of these puppies will also be recessive reds.
Yeah.
Now, to the most kind of messy part of it today, I would say, it's the white. This is what, science hasn't completely figured out yet. It's called the S series. I am not sure what this S stands for. And it causes, easily said, it causes the body to be unable to produce any pigment in the areas.
So pink eyelids and...
Pink eyelids, nose, any part of a dog that is white, it is caused by the S series. The Samoyeds, White Shepherds, Spitzes, this is a different gene that causes that, so we can leave that aside. But we're talking about the S series, and this is something that is thought to have incomplete dominance. Meaning that if the dog is a carrier of piebald or excessive white, then they will have more white than a dog that has both genes for a full colour or an Irish white, so-called Irish white, which we call show colours in Amstaf. The important part to know here probably is that more white can be, the excessive white can be carried without being expressed. So the self-coloured, the full-coloured dog without any white is the top dominant one here. The next one down the line is Irish white, marked by SI. The scientists are arguing that this might be caused by a different series, but so far we don't know, so we just... Yeah, and the next one down the line is SP for piebald. we don't have any self-colored dogs or dogs who don't have any white in the breed. Dog who has two dominant S series genes can have very little white, kind of top of the nose, in a little patch in front of the chest, at the ends of the toes. It can be also affected by mother's health during the pregnancy.
Okay.
So if the female has whatever kennel cough, something, the puppies can have more white there. And Irish spotting or Irish white is what we call show colours. This is more than the minimal white. It's the white colour, more the white blaze over the head. And it is interesting why it's thought that it might be caused by a different gene, because there are breeds who never have predominantly white dogs, like Bernese mountain dogs. They don't get full white dogs like we get in Amstafs. So this is their hypothesis. But a dog who has this S1 and is a carrier of excessive white SP is going to have more white on their body. So it's
also on the phenotype. So
on the phenotype, yes, on the phenotype they will have more white. It is kind of thought, it's not thought, it's known, that during the pregnancy, where the puppies, the embryos are still developing, the pigment kind of migrates from the top down. So this is what we can see in different levels of white of the dog. The last place the dog will lose the white is supposed to be around the ears.
Okay.
And you know, it kind of spreads down from the spine.
Okay. So for defining the dog's colors, we have 1, 2, 3, 4, 5, 6 different letters: B, D, A, K, E, and S. So I'm sure that we're going to talk about more in more detail about these topics. But now let's get few examples of breeding different color parents. So let's talk about this first, because this is something that has been raising a lot of questions, and some even. What I am actually surprised is. When I started with Amstafs and Dobermans, Kennel Pure Power is established on 1995. I didn't know shit on that time about breeding or anything. I was doing sports with my Doberman. I made my first litter, and only now it's 2018, and I've only started understanding more about the genetics, the colors, the genes, the pedigrees, everything. But what I was actually really surprised that this even the basic color genetics is not that clear for some. I wouldn't say most breeders, but for some breeders. Have you noticed this kind of a thing?
Yes. Because I think it's you need to constantly continue your education, but at some point it is possible that the very established and successful breeders who've been breeding for decades, they kind of, they maybe are not actively seeking out new information. And the color genetics, as I said before, it is constantly evolving. Our knowledge of the different genes affecting the dog's color is constantly evolving. And, you know, it is kind of the brindling thing. It doesn't.
Let's have one example.
Okay.
The mother is red, and the father is red. What can you expect the puppies to be by colors?
Well, red. They can have, theoretically, they can have dilution. They can have blue. They can have tricolors. They can have liver. It depends what you cannot get from there is black puppies. Correct me if I'm wrong. If there is a recessive black in the breed, point me to it, please. I will appreciate that. You cannot get brindle. And this is something that is really relevant. The pedigree for 4, 5, 6 generations can be all brindle. From 2 reds, you are not going to get a brindle puppy. Mm-hmm. Like I said before, a puppy gets 1 gene from to kind of each alleles from 1 parent. Mm-hmm. If neither of those parents have a brindle gene to give, and if they're red then they don't, then the puppies cannot have brindle. Mm-hmm. It might be, we can talk about other breeds like whippets who might have the hidden brindle. Mm-hmm. Because they have also dogs that have very little brindling. Mm-hmm. In Amstafs, we don't. Yeah. We don't have these dogs that have so little brindling that they can kind of hide it.
Okay, so colors for dummies. Red parents, red mother, red father, you will get basically everything else, but not black and not brindle. Because one of the parents' phenotype needs to be brindle.
Yes. In order for the puppy to be able to be brindle, one of the parents needs to have a brindle gene to give them.
Okay. What about if the mother is red and the father is brindle? What's the difference of the previous one?
Well, then one parent has at least 1 brindling gene, so the puppies can have the brindle. So it's if the parent who is brindle has 2 brindling genes, then all the puppies will be brindle.
What do you mean 2 brindling genes? Both parents are brindle or what?
No, if the mother is red and the father is brindle, mm-hmm. then they have at least one brindling gene, so called, in the K series. Mm-hmm. In case they have 2, then they will pass on one of those genes to their puppies, and if both of them are brindling genes, then every puppy will get 1 brindling gene, which means phenotypically they all will be brindle, and genotypically they will all be red carriers.
This is more advanced information now, so please try to explain with these letters that you have. So the mother is red.
That means
that means that the mother also can have this KBR.
No.
There. Okay.
No, there is
so the KBR needs to come from the father's side,
yes.
whose phenotype is also brindle.
Yes.
So can you please give an example with these letters? Let's leave the nose and everything out. But when you say that it needs to have 2 of these brindling genes, so are you saying that it needs to be KBR?
For puppy to be brindle, one of the parents...
In this case, that all the puppies are brindle.
Then one parent needs to be KBR.
Yeah, that's what I was asking.
Yes.
Okay, so that's clear. But this is something that you can't see from the phenotype. You need to have a gene test for that,
yes.
right?
Yes,
okay.
You can't see if the dog is a red carrier or not. Mm-hmm.
But okay.
Punnett square is a really easy way to kind of visually draw out these simple genes. Google Punnett square, Punnett square. It's easy and it makes everything really clear, and the likelihoods of the dogs, giving how many brindle, white, whatever puppies. Mm-hmm. So that's nice.
Okay, that's about some examples. So what we know here is that 2 red parents cannot give brindle puppies. Yep.